Hi, I'm Chao Liang. Today I will be discussing the accuracy and latency of signal processing techniques, and we will introduce three main techniques: short-time Fourier transform, wavelet transform, and empirical mode uh, composition. We can start by looking into the application of signal processing techniques. Given a non-stationary signal, we can transform it into frequency domain using Fourier transform. We can use wavelet transform to evaluate the signal at different scales without any transfer function. We can also decompose the signal based on the empirical method. Basically, they can simplify the raw signal and make it easier to find features. Theoretical foundation is crucial for us to understand the performance and application of the techniques. For STFT, actually it's based on Fourier transform, but the difference is it firstly divides the signal into many segments, and then they use the Windows function to avoid the spectrum leakage problem. After that, they apply the Fourier transform to each segment, and then they can reconstruct the spectrum. So after that, we can get a matrix including time and frequency. The wavelet transform is based on another idea. We try to use the convolution between the raw signal and filters. And the filters actually is based on the different wavelet functions. And the functions can have different parameters like scales and translations. The larger scales corresponds to the lower frequency, and the translation corresponds to the positions within the signal. So after we use the wavelet transform to process any signal, we can convert it into another space of translation and scales. And it's similar to the concept of time and frequency. Empirical mode computation is a kind of day-drive method which can be used to decompose the signals. Firstly, they try to find the maximum and minimum of the signal. Then they can have upper and lower envelopes. They calculate the mean envelope of the two envelopes, and then they subtract the mean envelope from the original signal. So they can have the first intrinsic mode function. And after that, they can repeat the shifting process until they get into the criterion. Regarding the accuracy and latency, firstly, for STFT, it has good frequency resolution, but it suffers from spectrum leakage. And about the latency, it has large computational load due to its algorithm. Moreover, due to its overlapping windows, so it actually have larger latency. For wavelet transform, it has good time frequency localization, and it has smaller spectrum leakage. And it has smaller computational load compared to short-time Fourier transform. For EMD, as we mentioned, it doesn't require prior knowledge of the signals, but the drawback is It requires interactive shifting process, so the computational load can be large, especially when the signal is complex. Currently, there are many systems which use signal processing techniques. Here is a picture which describes a simple MC system. Firstly, they use the SDFT to convert to the time domain primary signal into frequency domain. And then they can use the FX LMS to process the filtered signal. After that, they can use the inverse SDFT to recover the frequency domain to time domain signal. So that's how the SDFT can be useful in the MC system. And moreover, there is a growing interest in the wavelet transform and EMD, which can be used to MC all other systems. In conclusion, each signal processing technique has its own strengths and weaknesses. The choice of technique depends on the specific requirements of the application in terms of accuracy and latency. Thank you for your attention.